In this lesson, we are going to be using the law of sines to apply trigonometry to non-right triangles. So I want to make sure you understand that when we are working with this lesson, that you need to have non-right triangles. If we have right triangles, then we can use our laws of trigonometry, SOHCAHTOA, to solve for angles of a right triangle. We can also use the Pythagorean theorem to solve for sides of a right triangle. So this can also be called the law of sines or the rule of sines. And so what we want to establish is that there is a relationship between the angles and the side that is opposite the angle. So we name our angles with capital letters A, B, and C, and then the side opposite of that angle we name with the lowercase letter. So for example, this angle has a relationship with this side, which is the lowercase a. Capital B, as we name this angle, then has a relationship with the side opposite of it, which we would label as lowercase b. And angle C then has a relationship with its opposite side, which we name as lowercase c. We can set up, using the law of sines, that the sine of angle A in a ratio to the side A, and we can also then do the same thing with the sine of B, relationship to the side B, and a ratio of sine angle C to side C. You can also, if it's easier, depending on the problem, we can also use the reverse or the reciprocal of these. So A, side A, in ratio to the sine of angle A. Side B, we can set up a ratio to sine of angle B. And side C, we can set up as a ratio and have a relationship with the sine of side C, whichever is easiest as we begin to solve. Now, one thing that's really important to understand is that the relationship between the angle and the side, that as the angle becomes larger and more spread apart, then the length of the side increases. And as the angle becomes smaller, then the length of the side becomes smaller. And it's important that we understand that there is a corresponding relationship between the size of the angle and the length of the side. Let's do an example. We are going to do one that involves angle, angle, side, or angle, side, angle. And those terms should be familiar to you from geometry. So what we want to do is set up a proportion, two ratios equal to one another, to solve for our missing sides, and we can use the relationship we know that a triangle has 180 degrees to find the degree measure of our missing angle. So 103 plus 28, when we subtract that from 180 degrees, we know that this angle has a measurement, angle A, of 49 degrees. So now what we need to do is to solve for side C and solve for side A. So the first thing that we can do is to set up a relationship that the measurement of side B, which is 26 feet, and we set up that ratio to the sine of angle B, and angle B is 28 degrees. Then we can set that equal to one of the sides that we don't know. So we could set that equal, for example, to side C, which we're looking for, and that would be in a ratio with the sine of angle C, which is 103 degrees. Then all we need to do is to solve. So the way that would work is we could use a proportion, or we can simply multiply this ratio by the sine of 103 degrees. So the sine of 103, we're going to multiply both sides by that, and we have our ratio of 26 to the sine of 28, and that is equal to the length of side C. So plugging that into our calculator, then we can find out that that equals approximately 54 feet. When we round to the nearest tenth, it comes out to be about 53.96. So rounding to the nearest tenth, then C is going to be equal to approximately 54 feet. Now we can use the same concept to solve for side A. It is easier if you put the unknown in the numerator or the top of your ratio, and easier to solve and set up that way. So let's use our same ratio because we are given that B is 26 feet and we were given that the measurement of angle B is 28 degrees. So using the law of sines, we can set up our ratio that the length of B 26 over the sine of B, the sine of 28 degrees. And then we want to find what side A is, so we'll put A over the sine of 49 degrees, and that's what we calculated. So we can simply multiply both sides by the sine of 49, and then we can use our calculator to finish calculating and find out what the measurement is of that particular side. And that comes out to be about 41.8 feet for side A. Not a difficult concept when you just have to remember that we set up our ratios into a proportion and solve for either the missing side, or we can also solve for the measurement of a missing angle. Now, something that we do have to remember is that not every measurement that we are given actually creates a triangle. For example, some of the triangles, when we are given in a side angle case, if we were to draw them, we would find out that some of them, the measurements that were given, that some of the sides would be too short, some of them would be exactly a 90-degree angle, and some of them would actually be too long. So here are some ways that we can tell if actually it is possible that the measurements would create a triangle. So if angle A is an obtuse angle, then if the measurement opposite of side A is less than or equal to the other measurement that we're given, that would not be possible and there would not be a triangle. But if side A is greater than the other measurement that we're given and it is an obtuse triangle, then we know that it is something we can solve and we would have one triangle. Now on the other hand, if angle A is an acute angle, then these are some of the tests that we can use to figure out if it actually has measurements that are possible, and we can finish solving. So if we are given angle A, side B, and side A, we can multiply B times the sine of angle A, and if it is greater than side A, after we've multiplied, it is not a triangle. But if it is equal to, then it is one triangle. Now, if A again is an acute triangle, B times the sine of A, if it's less than A, and then therefore that's less than B, it would be two triangles. Or A, the measurement, is greater than B, then it is one triangle. So let's take a look at one of these cases, side angle. We are given the two measurements. We know we have angle C, side C, and then we're given measurement of A. So what we can do, since it is one angle that is an obtuse angle, we're going to go back to our slide, our obtuse angle, which is 122 degrees. So we need to compare the side that matches the angle given to us. So this is going to be side C instead of A. But that doesn't matter as long as you have one side and one angle that you have the relationship. Then you're going to compare it to the other one that you're given. So we want to, in this case, compare side C, which is 18 centimeters, and we're going to compare that to the other side we were given, which is 12. So we know that 18 is greater than 12. Since 18 is greater than 12, it is a possibility, and we can solve to find the other measurements of our triangle. It is one triangle. So we are going to set up our ratios or proportion, and we're going to solve. So When we set that up, if our obtuse angle is 122 degrees, we want to look for the other two measurements. So here we have 122 degrees, and that's going to be angle C. And the side opposite of that is 18 centimeters, and that's going to be side C. Then we simply put in that the measurement of the side A is 12 centimeters, and we are going to look for angle A, and we don't know side B, and we don't know angle B. So let's set up our ratios and then our proportion to solve. So if we have the sine of 122 degrees, which is angle C, we can compare that to side C, which is 18 centimeters. Then we can look for the sine of angle A, is what we're going to look for. And that would be compared to 12 centimeters. So what we will do to solve is we will multiply both sides by 12. So we have 12 times the sine of 122 divided by 18, and that should equal the sine of angle A, which is our theta. When we multiply that out and do our mathematics on our calculator, we get 0.57, and that equals the sine of angle A, or theta. Now, what we'll need to do in order to finish solving is we simply need to take the inverse sine to find out our degree measurements. So we want the inverse sine of 0.57, and when we use our calculator, that comes out to be 34.75, or about 35 degrees. Now, since we know now angle A is 35 degrees, we can simply know, because a triangle has a sum of angles of 180 degrees, we can subtract to find our other angle B, which is 23 degrees. Now we're still looking for side B, so we can set up the relationship that the measurement of side B compares to the sine of angle B, which is 23 degrees. And then we can set that equal to the ratio of side C, 18 centimeters, compared to the sine of angle C, the sine of 122 degrees. Now when we solve, we're going to simply multiply the 18 divided by 100, the sine of 122 degrees, by the sine of 23 degrees. And when we use our calculator, we find out that B then is equal to 8.3 centimeters. In the next example, again with side-side angle, we have our angle B is an acute angle. And if we go back to our other slide, when we have B being an acute angle, what we need to determine is if this will actually be a case that works. So what we need to do is find that A, which is 4 inches, if we multiply that by the sine of 58 degrees, is that going to be greater than side B, which is 2.5 inches? Well, when we use our calculator to multiply that out, we get 3.39, and that is not greater than 2.5. So this would not be a triangle, and we wouldn't be able to solve to find the other sides. So to review, in order to use the law of sines, what we need to do is to check our possibilities always of our triangle if we have a side-side angle case. If we have cases that are angle side or angle side angle, we should be able to use the law of sines and set up our ratios and proportions in order to find the measurements of the sides and the other angles that we have missing. If we have side-side angle cases, make sure that you check if angle A, or the angle that you are given, could be B or C, is an obtuse angle. Please check that the side opposite of that angle is greater than the other side given to you. If not, it is not a triangle. And then if you have A, or the angle given to you is an acute angle, what you want to do is check that using these sign relationships, or simply A is greater than B. If that works, then you're able to solve for the other parts of the triangle. If it doesn't, then it is not a triangle and you can't solve.